Yeah, let's start, sir.
Okay, sir. So, hello everyone. Good evening. First of all, let me know if I am audible or not. Screen sharing if it is okay. Yeah. So today we are going to start with this process control and optical instrumentation part. So first thing first, process control we are going to see. So syllabus for process control, if you are going to see the last 5 year questions from process control, so there are like 2 to 3 questions asked for process control. Not many questions are asked, but the concept of process control, like you should be knowing the basic transfer function of proportional controller, integral controller, differential controller, PI, PID, composite controllers, that you should know. And if you know that, you can solve questions. So process control questions which are clubbed with your control system. So that we need to know. So little bit about myself. So I have completed my master's from IIT Hyderabad in systems and control or control system. I have 6+ years of teaching experience right now. So my gate rank in instrumentation, it was 96 in 2020 and 108 in 2014. So gate syllabus, if I talk, so the important parts that we have over here is this sizing of control valves. This is very, very important. And from PSU point of view, questions have been asked from this sizing of control valve, tuning of PID controller. So here we have to basically see your Ziegler-Nichols tuning method, ZN method. So this is also very important because maximum questions have been asked from this part. Next, very, very important and questions which are clubbed with other topics, those are your P, PI, PID. So we should know the transfer function of P, PI and PID, proportional integral, proportional integral derivative, all those things we should know. What is cascade control, what is feed forward, and what is ratio controllers, we should be knowing. Then there were few simple questions which were asked from synchro pair, servo and stepper motors also asked. From this part, time delay system, mechanical, hydraulic, pneumatic system components, questions are not going to be asked. This is my guarantee because these topics, they are very, very lengthy and those topics, it is basically theoretical topics. So questions are never asked. In the last 20 years, there are no questions from these topic, time delay system, sorry, mechanical, hydraulic, pneumatic, and system components. So I want to know if you have any doubts, you can ask me regarding this thing or any instrumentation subject topics. If you have, you can ask right now, or else we are going to start the session. So first question I would like to ask to you is, what do we mean by process control? What do you mean by process control? So what do we mean by process? First, let me ask that. What do we mean by process? Anyone? Anyone want to say what is a process? So process basically means that we have a system. Okay, we have a system to which we give some input, something like this. So we have a system to which we give some input, or in real life you can say any raw material you give to get output. Okay, you get output, and this output is actually your desired product. So this is what we mean by your process. In a process, we give one input and we get one desired output. So that is known as what? Process. Now, any process, it needs to be controlled. Why it needs to be controlled? Because there are various factors like your disturbance, or sometimes even my input can vary, due to which this output may fluctuate, or we may get some undesirable product. So basically what we need to do? Basically we need to do what? We need to control the process In case of fluctuation, some external fluctuations, which we call as disturbance, or in case of some fluctuations in input, so that my output or the desired product doesn't becomes undesirable. So that is why we require what? We require the process to be controlled, and hence we call it as process control. Okay. So up to this point, any doubt if you have, you can ask me. Fine. So when we study process control, there are various types of variables. Okay. Various types of variables which we are basically controlling or monitoring, like your temperature as an instrumentation. If you are joining any PSU, your life will be around only this few parameters like temperature, pressure, flow rate. Okay, so these are the parameters that you are going to monitor or you are going to control. So basically, such kind of variables, they are classified on the basis as shown in the table. So all of this like temperature, pressure, flow rate, okay, all these things, basically what they are your process variable. Now based on whether they are input or output, means in a system, this is my input. Now, based on where this variable is applied, it is classified whether it is an input variable or an output variable. Now, input variable, it can be subclassified into two more parts. These are your manipulated variable and disturbance. Disturbance can also be subclassified into two, measured and unmeasured. Now, input variable, what do we mean by basically manipulated variable? See, manipulated variables are all those variables with the help of which we are controlling the system. Okay, we are controlling the system. Don't worry. We will take one example, and at that time, I will explain what is manipulated variable, what is a disturbance. So, no need to worry. First, just understand what is the textbook definition of manipulated variable. Manipulated variable are all those variables with the help of which we control the system so that we get a desired output. Okay, so that is your manipulated variable. And disturbance, everyone knows what is a disturbance. So any unwanted signal or any unwanted input, it is known as what? It is known as disturbance. Now few of the disturbance we can measure, few of the disturbance it is unmeasured. So those parameters or variables of disturbance which we can measure are known as measured disturbance. Those we can't measure is known as what? It is known as your unmeasured disturbance. Okay. So up to this point, everything clear? Now output, it is simply classified into two parts, measured. So all the variables which we can measure, it is known as your output variable, measured output variable. And those variables which we don't measure or which we don't need, means for our process parameters, we don't need, those are known as unmeasured output variable. Okay. So now up to this point, we studied process control from a control system point of view or from instrumentation point of view. But process control, can anyone else tell me from management point of view why we require process control? Suppose if you are a manager of a company, okay, why do you need to have process control, or why do you need to have a team which is actually controlling the process? Now, in that team, there will be some people from instrumentation, some people might be from safety, some people might be from environmental science. Okay, so operation management also, some people will be there. So, why do we require process control? Anybody? See, basically, process control, if you are giving input, so one of the thing will be that there will be some cost of the input. Okay. cost of the input. So your team, one of the criteria of this team, it will be that at the minimum cost, my output or my profit, because by selling the output only, whatever is your desired product, by selling that you will be generating profit. So basically this process control team, one of the operation management team, they will be doing this process control so that for maximizing the profit. I told them there will be some people from safety also. So what will be their criteria for the process control team? Their criteria will be that by minimizing the hazard, I need to get the best product. Okay, I need to ensure safe environment. Now there will be someone from environmental team. They are going to see that we need to basically have a sustainable process so that by minimizing the damage to our ecosystem or environment, I need to get this output. Okay, so process control from an instrumentation point of view, we are going to study, but process control is a very, very vast topic and it is even studied in your business or management school. But there, basically, our parameters will be different. It will be like operating profit, maintaining product quality, improving the safety, all those points will be there. Okay. So, any doubt up to this point? So at this point of time, process control, you might say, sir, we have PLC, we have DCS, distributed control system. Yes, all those things we have. Now, can anyone tell me what is the advantage of process control? Advantage. See, these are all basic questions asked in PSU. So what is the advantage of advantage of process control? What is the advantage of process control? See, the advantage of process control is that I have told all the points, okay? I have told all the points that we can regulate the process, okay? Regulate the process so that we get a better quality product output, okay? Better quality product. So our first is what? Better regulation to get the best output. Second point, see, many of you are going to be skipping this process control part, but process control, it might not be important for gate exam, but it is very, very important for PSU. So those students who are preparing for PSU, this subject is very, very important because many questions are going to be asked in your PSU interview from this process control. Okay, so study this topic if you are preparing for PSU, and even 2 to 3 marks questions are asked in your gate exam also each year. Next, maintaining safety or minimizing safety hazard and environmental damage. Okay. Third point. What is my third point? So higher efficiency. I need higher efficiency. Okay, higher efficiency. Now, what can be the disadvantage? Disadvantage of process control. See, if your process is basically non-linear, time varying process, then basically it will be very, very difficult to monitor the process. So disadvantage is that if my process is non-linear, time varying, so most of the real life system, it is basically what it is, your non-linear and time varying system. So for maintaining or monitoring such type of system, it is very, very difficult. So write it down. most of the systems, real life systems, are non-linear and time varying. So monitoring those systems are very, very difficult. And second thing is that we don't have exactly what all parameters we need to measure. So unavailability of exact accurate measurement. Okay, exact accurate measurement, it causes problem. Okay, so first point I said what? Maximum process, most of the process in real life, they are non-linear and time varying. So basically those type of process are difficult to monitor or control. Second is that unavailability of exact accurate measurements. Okay, so those 2 points you can write. Now let us see what we have understood from the previous slide. So what is your input variable? What is your output variable? In our input variable, what is manipulated variable? What is disturbance? In output variable, what are the measured variable? What are the unmeasured variable that we are going to see? So this is basically a CSTR process, continuous stir tank reactor. Okay. In short, it is known as CSTR, continuous stir tank reactor. So here we have a agitator. So agitator is nothing but it is kind of like a spoon, and constantly we are stirring this liquid inside this tank so that uniform temperature T is maintained. Okay, so this is kind of a big spoon, you can understand, through the help of which we are continuously stirring this liquid inside so that uniformity is maintained. So here we have a tank basically. In that tank, we are filling water. So the flow rate of the water, input flow rate of the water is Fi, and input temperature of the water which is going, it is Ti. So this is the level of the water H inside the tank. And our main purpose is what? That we need to heat this water to a certain temperature T naught, certain temperature T naught with the help of the steam. Okay, steam is passing through this line. So now can anyone tell me what are going to be my input variable, output variable, and manipulated variable? What is my input variable? What is my output variable? And what is my manipulated variable? So tell me, what do you think will be the input variable, output variable, and manipulated variable? So input variables are going to be my, see, I have also mentioned flow rate of the water flowing inside the tank and input temperature or the initial temperature of the water. So Fi and Ti are going to be what? It is going to be my input variable. Output variable, basically it is my T naught. So this is what I am trying to control, or this is basically what? This is my desired value. Desired value of the controlled variable, also known as set point. So this is my set point. Okay, this is my set point. Remember this, that the desired value of the controlled variable is called what? It is called my set point. Okay, T naught, this is what I desire. This is what I want. Now, what are going to be my manipulated variable? Manipulated variable out of these two, suppose if the temperature of the steam is constant, because wherever we are converting the water to steam, temperature of the steam will be constant. Okay, temperature of the steam, it will be constant. So by varying the flow rate of the steam, suppose if the temperature of the water is dropping, so what I will do, I will increase the flow rate of the steam. If suppose the temperature of the water has risen near to this T naught, suppose if T is approximately equal to T naught, so what I will do, I will decrease the flow of the steam. Okay, so my manipulated variable over here, it will be what? It will be my flow rate of steam. Now, what all can be the disturbance? disturbance. Now, one of the disturbance, it can be what? It can be basically Fi and Ti. Why? Why Fi and Ti? See, suppose if flow rate increases, what will happen? The temperature of inside this tank, it will drastically reduce if what? Fi is less than T. Sorry, if Ti is less than T. So what will happen if I increase the flow rate? What will happen? The level will rise and there will be more cold water. So due to that, that is one disturbance. If suppose Ti, this is input temperature, this is also a disturbance. Why? Suppose if this is a water heater, a water geyser. So in winter, Ti will be less. In summer, Ti will be more. Okay. So basically, this is also a disturbance. Any other disturbance that we have over here? Any other disturbance? Yes, there are two more disturbance. F naught. F naught. If suppose what happens, F naught suddenly increases. So in your home also you might have seen when there are, if you have multiple bathroom and there is a single geyser, if all the taps, hot water taps of the bathrooms are opened, you will get a little bit colder water compared to if a single tap is open. So F naught is also a disturbance. If flow rate suddenly increases, what will happen? My flow rate to maintain the temperature, this temperature equal to T naught, this FST needs to increase. Even this TST, this is also a disturbance. Suppose if we are burning gas, okay, gas to produce this steam. Now, if the quantity of gas is suddenly decreasing, what will happen? The steam, it will also reduce. So this is also a what? This is also a disturbance. So up to this point, any doubt, please let me know. Any doubt, anyone? Doubts? So note this down. This is very, very important. You need to understand what is your manipulated variable, what is your set point. So set point is what? It is the desired value of the controlled variable. Okay, desired value. That means what? This T, when it reaches T naught. So T naught is my desired value. This T is actually what? This is my instantaneous value of the temperature of the water inside the tank. Okay. Any doubt up to this point, please let me know. Okay. So next is open loop versus closed loop. What is open loop? Can anyone tell me? What is closed loop? So open loop, closed loop. So open loop is that loop where we basically don't monitor the system. Manually, we monitor the system. There is no feedback present. In closed loop, basically what we have a feedback element or the process is monitoring itself. Monitoring itself. Okay. So basically feedback, what it does, it adjusts the manipulated variable. Understand, manipulated variable according, what is the manipulated variable? Manipulated variable. See, I have told this is your manipulated variable. Now, what is this manipulated variable? Here I told that this is FST is the manipulated variable. The one more thing I will say, there is one more definition of manipulated variable. Manipulated variable, it is the input to the controller. So what is the input to the controller? So this is my C output from control system. This is my R. So this is my error. Error is what? R minus C. If this is my negative feedback system. So error is equal to R minus C. So basically, in feedback, it adjusts the manipulated variable according to the difference between measured variable. So this is my measured variable and this is my reference, or this is my set point. So whatever, basically, in our open loop, sorry, in our closed loop, my feedback element or my controller, simply this controller, it is monitoring this error. The moment this error is equal to 0, error equal to 0 means what? Set point is equal to my measured value, or whatever is my desired output, it is equal to my actual output. Please tell me, is this clear? Whereas in our open loop system, there is no such feedback. Manually, you need to do what? You need to measure, or you need to basically do what? You need to act as a controller, so that for a particular input, you get a desired output. Okay. For a particular input, you get a desired output. Now, a very simple example is what? Air conditioner. Air conditioner, you set it to 27 degree, and your room temperature, it will be maintained near to 27 degree. Whereas for your fan, okay, ceiling fan, if you feel warm, what you need to do, you need to increase the speed of the regulator, you need to switch it to 5. If you are feeling cold, what you need to do, you need to decrease this value to 4 or 1. Okay, depends. So this is what we have. This is your open loop where you need to take action. Whereas in your closed loop, basically what you, there is, once you have given the set point, automatically the controller or the process itself going to take care of itself. Okay, any doubt in this? Fine. So now let us see some different kinds of control. So one of them is regulatory control, another is servo control. So what do we mean by regulatory control? So in regulatory control, basically my main aim is what? In regulatory control, my main aim is elimination of disturbance. That means what? I need to eliminate whatever external disturbance is affecting my system. I need to eliminate that. Okay. Whereas in our servo control, what is my main aim? My main aim is that controlled variable should follow set point. Okay. So that means what? My controlled variable should follow the set point. Whatever change in set point I am making, basically my output should be able to track that, or it should follow that. Now let us understand regulatory control and servo control with the help of an example. Okay, so in regulatory control, basically my main aim is to eliminate the disturbance from the system. So here, what is the definition I have written? Deviation of the output due to disturbance from set point and minimized by changing input to the system. So for this simple example, suppose in the evening, the consumption of electricity, it is more, sorry, it is less compared to whatever consumption is there in the morning. Why so? Because in the morning, all your industries, it's working, all your malls, all your places, okay, whatever places, so there is consumption of electrical energy. So now grid is supplying energy in the morning as well as in the night. Power generation, whatever is happening in your thermal power plant or hydro power plant, it is going to be constant. Now basically grid needs to take action so that there is no overload, or there is no basically your overloading of the system. So in the night, there should be no overloading. Okay. Suppose this is the curve of the power. Suppose this is 6 a.m. and this is 6 p.m. This is 11 a.m. So there is maximum surge in power requirement. Now, basically, my grid control, what it does, it is going to control this spike sudden rise in power requirement, whereas it is also going to control when there is decrease in power requirement. Like during our COVID, there was this initiative by Narendra Modi, Honorable Prime Minister of India, that to switch off the light for like 15-20 minutes and we should light candles. Okay. So there was this hue and cry, okay, from non-electrical engineers and everyone from in Facebook or in Instagram, you might have seen there what there might be grid failure. Why? Because all over the India, everybody is switching off light, fan, and everything. So what will happen? There will be sudden rise in generation of the electricity, whereas the consumption it is going to go down. So at that point of time, grid control of India, they very well controlled this power rise as well as the consumption decrease in the power. So this is what we mean by regulatory control, that my controller, it should be able to what? It should be able to eradicate the disturbance from the system. Now, what is a servo control? In servo control, basically, my controlled variable, it should be able to follow the set point. As you have seen in your missiles. Okay, missiles. So it needs to do what? It needs to hit a moving target. Suppose this is my aeroplane. Okay. So this is going to go like this. So the missile should be able to track this movement and should try to hit it over here. So here what you can see, basically continuously my controlled variable is changing. Sorry, my set point is changing. So my controlled variable should be able to follow that. So in servo control, we basically do what? Our output, it follows trajectory, or my set point, it continuously changes. The controller should be such that output should quickly change. Should quickly change with the change in set point. Okay. Any doubt? Please let me know. Any doubt up to this point? Okay. So now let us try to differentiate between what is your feed forward control and what is your feedback control. Okay. Feed forward and feedback control. Okay. So few things I want to say over here in regulatory control. In regulatory control, our main objective is to control the load variations. Okay. Load variation means what? Basically, we want to control the disturbance, load variations. So in regulatory control, my main aim is what? Aim is to control load variations. Okay. Load variation. Whereas in servo control, my main aim is to go what? My main aim is that output should follow input. output should follow input, or what you can say, controlled variable should follow set point. Is that clear? Is that clear? Fine. So now let us study about what? Let us study about feedback and feed forward control, and what do we mean by feed forward control. See, in feedback control, it is actually very simple. Every place in control system we have studied your feedback control. So in feedback control, basically what? In control system, what we have studied. So our block diagram, it looks something like this. In a negative non-unity feedback configuration. So here we have this plant transfer function. This is our feedback transfer function or sensor transfer function. This is our, sorry, this is our set point. And this is our what? This is our controlled or measured output. Okay, controlled output. So basically in process control, we know that in Laplace, if we have blocks in cascade, we can multiply the transfer function. So this G is actually the multiplication of the transfer function of controller, final control element, and process. So what is this controller? What is this final control element? And what is this process? First, let me explain that to you. See, controller is basically the brain of this process control, because it take the decision. It is going to take the decision between your controlled output and your set point. It is going to take the input error, which is actually what? Set point minus your controlled output. Okay, whatever it is. So controller is what? It is the hub or brain of the control system or process control. Now, what is this final control element? So based on this, whatever error signal as input controller is getting, controller will take one decision or a decisive action it is going to take. And based on that decisive action, my process is going to be controlled. But who is going to take the task, or who is going to basically decode whatever signal is being generated by controller, or what corrective action should be taken by the signal generated by the controller, that is done by final control element. So example of final control element is like valves. So valve is what? Valve is my final control element. So basically it takes the output of the controller as input, and it produces an equivalent corrective action, so that my process my desired output, it becomes equal to my actual output. Okay, so that is what is my final control element. Example of controller, it can be what? It can be your PLC, it can be your computer. Okay, so now this measuring device, what is the task of this measuring device? So measuring device is actually going to measure what is my control value of the controlled output. So now this can be a simple sensor. Like in the previous case, in our tank case, how are we going to measure this temperature T? So what we are going to do, we are going to insert one thermometer and we are going to check. So if there was a feedback, so that this will be our measuring device. So this, whatever will be the output of this thermometer, it is going to be fed to this steam value. Okay, but this was what? This was your open system, open loop. So in a few minutes, we are going to see the closed loop version also of this one. So measuring device is what? This is basically a sensor which measures this value of controlled output, and it gives signal to this comparator, so that this comparator can compare it with the set point value. Okay. So this is our conventional feedback system. So now in our feedback system, if if there was any disturbance, suppose there is some disturbance coming. So how is this disturbance going to affect my system? Affect my system, that I want to know. Whether this is going to be affected after, means after the disturbance has entered the process, or whether this disturbance is going to be detected beforehand, that is before it is entering the system. What do you think? So basically you are very much right that level. Okay, so one thing I noticed suddenly that my chat section, it was not loading automatically. Now it is loading. Okay, fine. So what I was telling, that this, suppose there is a disturbance. Now, until and unless this disturbance has not affected my system, what will happen? If it has not, if it, when it affects my system at that point of time, this measuring device, it is going to see that this Y, this output, it has changed due to the effect of this disturbance. And due to that, my error signal, what will happen? It is going to change. The moment this error signal is going to change, controller will get an input and controller will generate an equivalent output and give that to your final control element. And final control element, according to the input output of the controller, is going to take a decisive action to minimize the effect of this disturbance. That means what? In the feedback system, my disturbance, it is negated after the disturbance has affected my process. Means what? After the disturbance has entered the process, it is going to be measured by this measuring device, and after that only my controller can take action to remove that disturbance. Means what? In feedback loop, disturbance has to affect the process to get detected. So tell me, is this a good thing? Suppose you are preparing some finished good, okay, a very costly good you are preparing, or suppose medicines, your process plant is preparing medicines, where a very small change in the compositions of the medicine, it can affect the quality or potency of the medicine. So do you want the disturbance, any particular disturbance, to affect the process? Do you want that? You will not be wanting that. Why? Because if a disturbance is affecting, so what will happen? It is going to reduce the quality of your medicine or potency of the medicine, or it might even change the composition of medicine also. It might become some kind of hazardous process, okay, hazardous chemical kind of. So we don't want that. So to avoid that, what we have feed forward control. Okay, so there are some advantages of feedback system that I have written over here. Feedback system, what? It does not measure any disturbance. Why? Because we let the disturbance affect the system. We let the disturbance affect the process. After that, we are going to measure it. So we don't specifically measure any disturbance. Okay. So feedback configuration is insensitive to modeling error and parameter changes of the plant. Why so? So what is modeling error? Modeling error. See, in control system, when we were taking the controller transfer function, or see, if this G we are taking, so this G, it was looking something like this. If you remember, S divided by S square plus 2S plus 1. This was transfer function. So this is basically what? This is the Laplace transform of output by input. This is what we call what? Transfer function. When input is what? Impulse response. So this is basically the modeling, mathematical modeling of a system. So any system needs to be mathematically modeled. Now, if there is some modeling error, so feedback configuration, it will be insensitive. Okay, insensitive. Why? Because if there is some error present over here, and if we are giving the system a certain set point, so what will the system, basically my controller, what it will do, it will negate the effect of this modeling error automatically. If if what, if my transfer function is stable, then only it can do so. If my transfer function is unstable, then for any input I cannot get a stable output. Okay, but if my transfer function is stable, completely stable, or proper transfer function is there, for any set point, even if there is modeling error, suppose if I have done s plus 1, then also for a particular value of input, I will get a particular value of output. Okay. So it provides better accuracy, transient and steady state response. This we have already seen in our control system. This is already seen. Now, what are the disadvantages? So it is unsatisfactory for process with large dead time. Now, what do we mean by large dead time? Suppose if we have a medicine manufacturing plant, where suppose at the 0th minute, if you give input, my final batch of medicine, it will be generated after 12 hours. Means the process cooking time is 12 hours. Okay, 12 hours it is taking. Now, if suppose there is some disturbance entering the process, so what will happen? The effect of this disturbance we are going to see after 12 hours. Why so? Because what? Because the dead time, or dead time means what? Dead time is basically the time taken by the process to show the effect of disturbance. That is basically 12 hours. So the process where we have a larger dead time, or where once the disturbance enters the process, the effect of that disturbance, it can be seen after a very, very long time. So in those process, feedback system is very, very bad, because for negating or eradicating the effect of that disturbance, it will take very, very long time. Okay. Next disadvantage is what? Instability in closed loop response. So this is very important. In the last case only, I told that if my transfer function is proper transfer function, then only I can use feedback. If suppose this is improper transfer function. Now, what is improper transfer function? That is order of numerator is greater than equal to order of denominator of the transfer function. So if it is improper transfer function, then what will happen? Basically, my system, it will become unstable for any kind of inputs. Okay, so that should be avoided. Next disadvantage is that this is expensive and complex to implement. Okay, why so? Because we have this measuring device, usually sensors are costly. Okay, so that is why this is a complex process also, because we require modeling of the process, mathematical model. And usually, see, our control system, always this part is given to us, transfer function is given to us, but calculating the transfer function, it is not that simple. As we see theoretically, that whatever is the impulse response, if we take Laplace of it, we will get the transfer function. That is a theoretical thing, but practically it is very, very difficult to obtain the transfer function like that. Okay, because why? Can anyone tell me why it is difficult? Because ideal impulse signal, it is not possible to generate. Okay, so that is why calculating the transfer function is also very, very difficult. Fine. So next is what we have, this feed forward control. Okay, feed forward control. So in feed forward control, basically what will happen, that this disturbance, see, previously in the feedback case, disturbance was getting measured after it has affected the process or after it has entered the process. But in feed forward control configuration, my disturbance before entering the system only, it is going to be measured by the controller. It is going to be sensed by the controller. The controller is going to beforehand sense that certain disturbance is going to enter my process and I should take a corrective action. Okay. So basically the controller is taking corrective action based on the disturbance or anticipating the effect of disturbance. So, okay. Did we understand this? See, previously in feedback loop, my disturbance, it was getting detected after it has entered the process. But in your feed forward loop, the controller, it is going to detect this disturbance before it is entering the process and it is taking corrective action. So that is why feed forward control configuration is called as what? It is called as your anticipatory control. Anticipatory control. It is called as anticipatory control. Is this clear? Anticipatory means what? It is basically anticipating the disturbance. Anticipating the disturbance beforehand and taking corrective action. Who is anticipating? Controller is anticipating the disturbance. So what I have written over here, the controller basically measures the disturbance as it enters the process, uses a controller to adjust manipulated variable. Controller is actually taking corrective actions or manipulated variable to control the process due to the effect of this disturbance. Feed forward control is known as anticipatory control. Now, any example of feed forward control configuration? Any example? Any example of feed forward control configuration? So I have given an example over here that we are going to study. First, let us see your cascade control. Okay. So one by one, all the examples also we are going to see. Okay. So next what we have is your cascade control. So what do we mean by cascade control? Basically, there is a master loop and there is a slave loop, or there is a primary control loop and there is a secondary control loop. Okay. You can see over here that this is my inner loop and this is my outer loop. Okay, this is my outer loop. So we have is inner loop and outer loop. Now, one thing very important is that the output set point, outer loop set point is actually giving the set point to your inner loop. What I said, the output, see, outer secondary controller, there are two controllers who present over here. One is primary controller, another is your secondary controller. So only to the secondary controller we are giving set point. Whatever is the output of the secondary controller, that acts as the set point of the inner loop or primary controller. Understood? So now basically, why do we have two loops present over here? Why do we have two loops present? See, two loops are present over here due to the fact that if in a process, understand very carefully what I am speaking. If in a process, one of the parameter has a larger effect on the other parameter. See, one of the process parameter, it has a larger effect on compared to one more parameter. So at that time we are going to use what? We are going to use cascade control. So a very small example is over here. You can see very small example. Let us try to solve it. You will understand the whole thing. Suppose this is your CSTR. Okay, this is your jacketed CSTR. Now, what do we mean by jacketed CSTR? In our previous CSTR, if you go and see, I was actually delivering heat through this steam line, okay? But in jacketed CSTR, there will be oil or there will be any fluid which is going to help us in this heat transfer, okay? So in jacketed CSTR, basically my fluid, it is going to flow through this jacket, okay? It is going to flow through this jacket. Now my main aim is same, whatever we have done in the last case, my main aim is same like that. So over here, basically what I have this coolant out. So this coolant is actually doing what? This is acting kind of a steam. Okay, you can consider instead of coolant, you can write it as steam. Steam out. This is reactant out, or you can even write it as water. So water output. So this is temperature T out, T output. And this is your T in, C in, or I can write it as flow in. Okay. Now, basically, in our feedback control, suppose there is a thermometer present over here. So this thermometer is going to sense the change in temperature. It is going to sense the change in temperature. So there is a temperature controller over here. Temperature controller. So this temperature controller, based on the set point given over here, based on the set point given, feed it to this controller. It is going to do what? It is going to maintain the flow rate of the steam. Flow rate of the steam in this jacket. So basically through this jacket, heat transfer is going to take place, and the fluid or water inside this CSTR, it is going to be maintained at temperature T. So there was only a single loop present over here, and that loop, it was basically getting feedback through the temperature of the water inside the tank. Please tell me, is this clear or not? So this is very, very important. If someone asks you to explain cascade control, this example is very, very important. Now, over here, my measured variable was this one. Okay, this was my measured variable. And I was taking feedback through this only. Now, this is what? This is my cascade control. Cascade control. You will see over here, same thing. See, this is steam out. Suppose from here, steam is getting out. From here, steam is getting in. So this is water out. So my output variable, my water temperature, it should be maintained at T. And from here, water is entering. So now at this point of time, I have two measured variables. What is that? One of the measured variable is same. Temperature of the water inside the jacketed CSTR. But there is one more measured variable, that is the temperature of the steam. Temperature of the steam. Now, what happens by doing so? See, this temperature of the water, it is going to be affected by the temperature of the steam only. If the temperature of the steam is high, what will happen? The steam will start rising very fast. If the temperature of the steam is less, temperature of the water, it will go down. So by basically doing what? By measuring this temperature of the steam, what I can do, I can judge the temperature of the water quickly. Suppose deviation over here, it was being measured in 10 minutes. By measuring the temperature of the steam, I can reduce this to 50, or sorry, by 50%, or within 5 minutes I can take corrective action. Why? Because as I am taking the temperature of the steam, so what will happen if suppose the temperature of the water is dropping, as well as the temperature of the steam has also dropped. So now my controller, see this TC1 and TC2, what it will do, immediately the flow rate of the steam, it will increase. Okay. Previously, I was taking corrective action based on this T. But at this point of time, I am not singularly dependent on T. I am also dependent on the temperature of the steam. So if temperature of the steam decreases, So automatically TC1, it understands that this temperature is also going to decrease. Or if this temperature is decreasing, so TC1 will send a signal to TC2 that immediately increase the flow rate of the steam inside this jacket. Are you getting the point? What is happening? Previously, based on this single measurement, my controller was taking action. Now I have two variables with the help of which I can control this T. So what happens when we have cascade control? Basically, we can reduce the dead time of the process. Okay, dead time of the process I am reducing. Please tell me if this is clear or not. Is this clear? So this is what we known as your cascade control. Cascade control. Okay, cascade control system. So here you can see basically we have two loops. Okay, so this is your secondary loop and this is your primary loop. So input of the secondary loop is actually the output of primary controller, or the set point of the secondary loop is the output of the primary controller. And here we are measuring two parameters. Why we are doing so? Basically we want to reduce the dead time. Or what is dead time? Dead time is the time taken by the process to detect the presence of disturbance in the process. Okay, so one thing very important that we need to know is current generated by electronic controller in absence of a signal, it is known as controller offset. So that means what? This I have specifically written over here because once there was this question asked, what is controller offset in your engineering services? So controller offset is basically what? It is the value of current or the signal when there is no input to electronic controller. At that time, whatever output I am getting, that is known as controller offset. Okay, any doubt? Any doubt, anyone? Okay, fine. So next we have is feed forward control. So feed forward control already we have seen. Okay, feed forward control. What is feed forward control? So feed forward control, as I explained it to you, that the effect of the disturbance before entering the process, it is being detected. My controller, it can take action before the disturbance has entered the process. Okay, so that is what is known as feed forward control. Now let us understand feed forward control with the help of an example. So in feed forward control, we have a boiler drum. Okay, boiler drum. So in boiler drum, like in thermal power plant, it is a very critical equipment, critical system. Why so? Because in our boiler drum, lot of steam is generated, very high pressure. It is a very place, means in that boiler we have very high pressure, and it is very safety critical, because if there is very high pressure, what might happen, that the boiler drum, it might explode. And if suppose the level of the water, it has decreased in the boiler drum, and if we are running it dry, what will happen? Scale will accumulate on the inner surface of the boiler drum. Due to that, less amount of heat transfer will take place inside this. So boiler drum, controlling the level of the boiler drum, pressure inside the boiler drum, it is very important. So now if in a thermal power plant, suppose understand, we require steam. We require the steam to do what? To basically maintain the flow inside the turbine. Okay, we need to maintain the rotation of the turbine. So now if suppose suddenly there is a spike in power, the requirement in power generation will increase, so my steam will increase. Now the moment steam increases, what will happen? So there will be a flow transmitter, so it is going to sense that steam requirement is getting more, So immediately it will send a signal to this feed forward control that increase the feed water, increase the feed water. So what will happen? The level of this boiler drum, it will be maintained at H. It will be maintained at a constant level. So you can see that if suppose if this was a normal feedback system, after the requirement of steam has increased or after this level H has dropped below a certain level, after that time only our controller would have taken action that feed water should be increased. But here this was not the case. Previously only steam, as the requirement of steam increased, this flow transmitter, it measured this, and feed forward control, it took an action, corrective action, and immediately feed water increased to maintain this level at H. Now, if suppose suddenly my power requirement decreases, suddenly it decreases, so steam requirement will decrease. Now, what will happen if steam requirement decreases? This flow transmitter, it will immediately sense that requirement or flow of steam has reduced. So feed forward, it will generate a signal or give to this feed forward that cut off or shut down the feed water to this. Previously, what would have happened if this was a feedback system? My level, it would have increased beyond a certain point, then my system would have detected, and then this feed water would have stopped. Okay, but in our feed forward control, before this deviation or before this requirement or before this disturbance affecting my system, I am taking corrective actions. Okay, so this is the block diagram of feed forward control block. Now homework for this, homework, what I want, let this be DS. Okay, let this be RS, let this be CS. So what I want you to calculate, CS by RS when DS equal to 0. So what will be the first transfer function? Next is CS by DS when RS equal to 0. What will be the transfer function? As this is your LTI system, so very easily we can calculate this. I want you to calculate because many a times in your control system, you will see questions like this. Unknowingly, we were solving the block diagram of feed forward without knowing that this is actually a feed forward control system. Okay. Next we have is ratio control. So in ratio control, basically ratio of two or more inputs are kept at a constant ratio, or ratio of two or more flows, fluid flow, are kept at a constant ratio. So this is a very simple example, is what it is, your internal combustion engine or your bike engine, car engine. So here in this particular case, we have to maintain what? We have to maintain the ratio of fuel and air. Okay, fuel and air, we have to maintain it. We twist the accelerator, what will happen? We press the accelerator knob of the car, fuel increases as well as the air intake increases. So in a particular ratio, the fuel is to air ratio needs to be maintained in your ratio controller. So in ratio controller, what we do? Two or more flows are kept at a constant ratio. Okay. So it is kind of a special type of feed forward control where two or more disturbance are measured and held at a constant ratio. So suppose if you want to increase the speed of your motorcycle, what you will do? You will twist the accelerator. So that will increase your speed. How is the speed going to be increased? Basically, the fuel going inside your engine, it will increase, as well as to burn that fuel, my air intake inside the engine, it will increase. If you want to decrease the speed, what you will do? You will simply leave the accelerator. So what that will do, it will simply cut off the fuel, and if the fuel is cut off, air should be also cut off inside the engine. Now if you want to maintain it at a constant temperature, sorry, constant speed, what you will do, you will keep the accelerator at a certain position held constant. At that time, the fuel is to air ratio, it will be maintained at a constant ratio, or the fuel flow will be constant. So due to that, air inside the engine, it will be also constant. So basically in our ratio control, what we are doing, we are keeping our ratio of two or more fluid or flow constant. Okay. So in our ratio control, one of the fluid is actually wild. Wild means what? We are not measuring it. Suppose in our bike case, air we are not measuring. Air intake we are not measuring. What we are measuring is fuel intake. So if we measure the fuel intake, basically what we will have, so we will be measuring what? Fuel we will be measuring. So based on that, if I have a certain amount of ratio, like fuel is to air is 1 is to 2. That means what? If 2 liters of fluid is going inside the engine, 1 liter of air should go inside the engine. So based on this, my controller, it will sense that I am not measuring the air. If suppose 100 ml fluid, 100 ml air is 100 ml fuel is going inside the engine, so according to that 50 ml air should go inside what? Inside the engine to keep my engine running properly. So there is one wild flow means what? The flow which we are not measuring, and there will be one measured flow. So there will be one flow controller, so in a particular ratio it is going to keep the ratio constant so that my process is running adequately. Okay. So with this, we are ending the first session of our process control. If you have any doubts, you can let me know, and you can join our iitiansgateclasses.com also for more such videos. And if you haven't subscribed to our channel, kindly subscribe to our channel. And if you like this video, if you have liked this video, please press the thumbs up button and as well as share it with your friends. Okay, so I will be ending the session. Thank you.